Hi folks, I hope that this video finds you well. Today we are going to continue on a few examples using the definition of derivative. I'll be writing the definition of derivative at each question, so I'm not going to actually remind you of what that definition is. So here we go. In order to use the definition of derivative to find the equation of the tangent, what we're going to do is write down the definition first. So limit as h approaches 0 of the difference quotient. The difference quotient looks a lot like the slope formula. F of x plus h. So I'm going a little bit to the right of f of x. And then this at the bottom would be x plus h minus x, but when you subtract those, you'll just get h. So here's your definition of the derivative based on in limit notation. So what we're going to do is just use f of x. So f of x plus h, if I substituted in x plus h, I would get the following. I'd get the limit as h approaches 0, and in the numerator it'd be 1 over x plus h. That's the same thing as 1 over x, but you're plugging an x plus h in for that x. And then it says minus 1 over x all over h. And what you might want to do is substitute in 0 for h, but what would end up happening is you would get indeterminate form. You would get this 0 over 0 deal. So you can't actually do that yet. So what you're wanting is for something to simplify. So in this case, we're going to be simplifying fractions. So let me grab my red pen and show you how we're going to be simplifying fractions. So what we're going to do is we're going to need a common denominator. All right? So let's go ahead and work through this thing. On the top, what I see is that I would like to have an x plus h in this denominator. So I'll put it in the numerator as well. So that's just like multiplying by 1. And on the left, on the term on the left, it will need an x so that the denominators are exactly the same. So the first term that I write is actually going to have a common denominator now. I said first term. Let me see. This is going to be x minus 1. Let me see. No, it'll be x. Let's go ahead and put this, make this a plus negative 1. Okay, so x minus parentheses x plus h all over x parentheses x plus h. And remember in 6th grade how they wrote the division symbol? They'd say something like divided by h. Let's go ahead and write it that way, because that's going to allow me to do the keep, change, flip strategy, that basically the division equivalent for multiplication, right? So anyway, what we're going to do is kind of distribute this negative sign through, and when you see that distribution happen, you notice that the x is canceled. So x minus x, that'll be 0. And then it'll just say minus h. So negative h is on top, and x times x plus h is on bottom. Now this says divided by h. Well, we're going to say multiplied by 1 over h. Well, in that case, there's an h in the numerator and an h in the denominator, so they can cancel. So I'm going to continue my work up here a little bit, gain me a little space. So here we go. Once everything is, once I've canceled something, it's wise to go ahead and substitute in the 0 for the h. However, what I'm going to do is just rewrite what I have, and then I'm going to drop that h in. So when we drop that h in, or I'm sorry, the 0 in for h, it just gives me x squared on the bottom. So negative 1 over x squared is the derivative. So f prime of x is actually negative 1 over x squared. And it'd be awesome to get a visual of that. So if you wanted to look at the graph of 1 over x and then the graph of negative 1 over x squared, feel free to do that.